Matter exists on Earth in the forms of solids, liquids, and gases, such as a rock, water, and air. All matter is made up of tiny, constantly moving particles called molecules. The kinetic molecular theory explains the properties of solids, liquids, and gases in terms of the energy of particles and the forces that act between them, based on the idea that particles of matter are always in motion. This energy of motion is known as kinetic energy, and the total kinetic energy of all the molecules in an object is called thermal energy. For example, when you compare the thermal energy of water in a small cup and a bathtub, water in the bathtub has higher thermal energy simply because there are more molecules. But in this video, we'll assume that they all have the same volume. Relating to the kinetic energy, thermal energy is lower for objects with slower moving molecules, such as solids, and higher for objects with faster moving molecules, such as gases. Solids have fixed volume and shape. This is because solids are made up of many particles that are tightly packed, leaving very little space between particles. Therefore, they have low kinetic energy and are harder to separate. With slower moving atoms than liquids and gases, solids have low thermal energy. Liquids have fixed volume but change their shapes depending on the container that they are in. The particles are less tightly packed compared to solids, so they flow easily. However, it is still not easily compressible. Liquids with moving particles have both higher kinetic energy and thermal energy than solids do. Lastly, gases do not have any constant volume or shape. In gases, particles are far away from each other, meaning that there are lots of free space between particles. With high kinetic energy and thermal energy, gases are easily compressible. This explains why kinetic energy or thermal energy increases as water goes from its solid state of ice to vapor by the end. The water's change of state can be seen through the heating curve of water. Let's look at the heating curve with time in minutes on the x-axis and temperature in Celsius on the y-axis. Keep in mind that throughout the whole time, the substance doesn't change. It's always H2O. With temperature below 0 degrees Celsius, water is in its solid state as ice. This solid ice heats up until it reaches 0 degrees Celsius where ice becomes water. This is the point where melting, the physical change of a solid to a liquid by the addition of energy as heat, takes place. There is no temperature change although the time is elapsing. As the solid becomes a liquid, the bond between the particles loosens, causing thermal energy to increase. During the second inclination on the curve, the liquid water heats up and goes into temperature change. Then, when more thermal energy is added as it reaches 100 degrees Celsius, evaporation occurs, which is the process by which a liquid or solid changes to gas. Again, as liquid becomes gas, thermal energy increases and particles are farther apart. As this gas heats up, we are just heating up vapor. Now, if we went the opposite direction, as steam cools and reaches 100 degrees Celsius, condensation takes place, which is the process by which a gas changes to a liquid. After condensing, as water cools down even more and reaches 0 degrees Celsius, its state of matter changes from liquid to solid by freezing, which is the physical change of a liquid to a solid. As temperature drops and gas becomes liquid and then solid, thermal energy decreases as kinetic energy drops at the same time. You can see that as the temperature goes up, water melts and evaporates, and it condenses and freezes as the temperature decreases. So by looking at the heating curve, we can see the points of phase changes. With these three phase changes, water changes into state from ice to water, water to vapor, vapor to water, and water to ice, which is basically the changes from solid to liquid, liquid to gas, gas to liquid, and liquid to solid. Depending on which state the water is in, kinetic energy increases or decreases along with thermal energy. And this is how kinetic energy is related to water's phase changes.